Hi, my name is Tamer Nawar, and I teach philosophy at the University of Groningen. Today I'm going to talk about Zeno's dichotomy paradox, which argues that motion is impossible. I'll have a look at what the dichotomy paradox is, and how one might respond to it. We don't know much about Zeno of Elea, but several of our ancient sources portray him as an associate or follower of Parmenides, and it's often thought that Zeno's paradoxes aim to support the counterintuitive claims Parmenides put forward. Whether or not that's right, what has come down to us are a number of arguments and paradoxes. The most well-known ones are the dichotomy paradox, Achilles and the runner, the arrow paradox, and the moving rose paradox. We'll be focusing on the first of these, but before we do so, let's consider: what is a paradox? For our purposes, we can say that a paradox is an argument towards a highly implausible conclusion on the basis of premises which are widely thought to be plausible and inferences which seem to be valid. Now, with that out of the way, let's have a look at Zeno's dichotomy paradox itself. Here's a brief report from Aristotle's Physics. The first paradox states that there is no motion because what is in motion must arrive at the halfway point before it arrives at the end. We get a longer description earlier on in Book 6 of Aristotle's Physics, and on the basis of those reports, it seems the argument goes like this. To get from A to B, one must first reach the halfway point between A and B, namely A1. But to get from A to A1, one must first reach the halfway point between A and A1, namely A2. However, to get from A to A2, one must first reach the halfway point between A and A2, namely A3, and so on. Because this can go on forever, it seems that an infinite series of journeys must be completed before you can travel any distance at all. However, that seems impossible. Now, let's try and sharpen the argument slightly by making it a bit more precise. So, if we were to break it down, it seems that the argument goes something like this. 1. To traverse any distance, one has to traverse half that distance. Now, any distance you like, whether it's 10 kilometers, 1 meter, or 1 centimeter, can be halved infinitely many times. So, 2. Any distance can be halved infinitely many times, into infinitely many distances. From 1 and 2, it follows that 3. To traverse any distance, one has to traverse infinitely many distances. But 4. It is impossible to traverse infinitely many distances. Therefore, 5. It is impossible to traverse any distance. That's the paradox. You might think that the conclusion is obviously wrong and that there's little more to be said. However, as philosophers, we're interested in determining precisely where Zeno's argument goes wrong. That means we either have to find a flaw in the reasoning so that some step of the argument doesn't follow, or we need to reject one or more of the premises. Let's assume that the reasoning is valid. That being so, if we want to reject the conclusion, what we need to do is reject one or more of the premises. So which one should we reject? Well, it seems attractive to reject 4. That is to say, the claim that it is impossible to traverse infinitely many distances. While 4 might seem plausible, it's not clear that it's true. An infinitely large distance is indeed impossible to traverse in a finite period of time. However, the sum of infinitely many distances doesn't need to be an infinitely large distance, just as the sum of infinitely many numbers doesn't need to be an infinitely large number. Let me explain by distinguishing between 2 different kinds of infinite series or sequences. Series A is 1 plus 1 plus 1 plus 1, and so on. This infinite series has infinitely many members, and insofar as we can speak of its sum, we would say that it is infinite. Series B is 1 plus a half plus a quarter plus an eighth plus a 16th, and so on. This infinite series has infinitely many members, but it does have a sum, namely a sum of 2. Here's an example which might be helpful in illustrating the difference between Series A and Series B. To illustrate the nature of Series A, imagine someone walks into a bar and asks the bartender for infinitely many beers, each beer being 1 pint. Now the sum of all those beers would be an infinitely large amount of beer. And just as it's impossible to traverse an infinitely large distance in a finite period of time, so too it's impossible to drink an infinitely large amount of beer in a finite period of time. To illustrate the nature of Series B, imagine someone walks into a bar and asks the bartender for infinitely many beers, each beer being half the size of the previous one. So they ask for 1 pint, and half a pint, and a quarter of a pint, and an eighth of a pint, and so on. Now the sum of all those beers would not be an infinitely large amount of beer. It would be 2 pints. And it is obviously possible to drink 2 pints of beer in a finite period of time. Now, if the infinite series that Zeno appeals to were of the same kind as Series A, then Zeno might have a stronger case for thinking that motion is impossible. However, Zeno in fact appeals to the same kind of infinite series as Series B, and it looks like that's where the paradox goes wrong. So to sum up, 4 claims that it is impossible to traverse infinitely many distances, but that doesn't seem to be true. It is impossible to traverse an infinitely large distance. However, the sum of infinitely many distances need not itself be infinitely large. If we reject 4, then we don't have to accept the conclusion of the argument, and it seems we've defused the paradox. Now that's not the end of the story. There are other ways to interpret this paradox, and Zeno also has other paradoxes to offer. Moreover, you might think there's something that can be said in defense of the dichotomy paradox. To be a little more precise, you might think that even though a person can drink 2 pints of beer in a finite period of time, there's something a little bit fishy about someone drinking 2 pints of beer spread out through infinitely many glasses in a finite period of time. That worry is connected to the nature of supertasks, actions or processes which are composed of an infinite number of components. Now I could go on, endlessly perhaps, but that's it for now. Thanks for your time.